All right, good afternoon. Pretty interesting talk to follow up. There seems to be like a little bit of AI versus Web3. What I'm going to try to do today is talk a little bit about Web3 and hopefully kind of try to unify this. And I don't necessarily see it as competitive as some others do. But before we get started, by show of hands, who would say they have a good mental model of what Web3 is? Okay, excellent. So we'll talk a little bit about that today. And this is a pretty broad topic. So what I'm going to focus on today is thinking about this new technology really from the perspective of the interaction of the individual user. So that's the lens that we're going to have here. There's, of course, many different facets to jump into, and that will be our guide. And essentially, we're going to cover two topics. What is it today, and where are we going? All right, let's dive in. So you can see I put a definition up here on the slide deck, but functionally what Satoshi Nakamoto did about 15 years ago, other than the fundamental thing of creating Bitcoin, this sovereign peer-to-peer currency, is really break conventional thinking. And what has occurred over the last 15 years is thousands of entrepreneurs and hundreds of millions of dollars rolling into building the new internet stack with distributed fault-tolerant backends that use digital signatures as the identity. And so it's a really kind of like 4-minute mile moment where once it was done once with Bitcoin, a whole new slew of people started to reimagine these systems with this different architectural lens, building things for an adversarial environment, expecting attacks, like going beyond a zero trust security model. And the really interesting thing for me is that the digital signatures here are used for authorization and identity. So let's talk about that a little bit. What are digital signatures? These are one of the foundational things, even outside of Web3, that are used in the internet. Every time you connect to your bank, every time you connect to a website, when you see HTTPS, there's digital signatures. It's essentially like the word noun, signature, is the right noun. You can think of it as a stamp, basically, for authenticity, saying that this came from me, that came from you. And we can go into the deeper level of the cryptography another time, but that's a good mental model here to just think about a signature as something that can authorize or authenticate one user or agent into a system or to another party. And so, as mentioned, we've got all of these thousands of entrepreneurs and hundreds of millions of dollars rolling into this new space. But why is Web3 better? You can see I put a couple different categories on here. I'll talk about a few of these from this list. So the sound self-sovereign money is generally pretty apparent, but one of the really exciting things about this is like, one of the core values of Bitcoin, for example, is that if you live in a country with dictatorial leadership, the old manner, if you wanted to leave that country, was to become a refugee, become destitute. But now you can put literally millions of dollars in your pocket, in your shoe, walk out of that country and go buy a new house in your new home. This is something that was not possible before when you had your capital locked up in real estate or in the bank of that country. And so that's one of the big stories. The other one that's really interesting is around data ownership, some of these non-financial use cases of Web3. The general mental model for how the internet works today is you show up to a website, you type in your username and password, and what you're doing is you're reading and writing data to that website server. For example, on Twitter, you're reading the tweets from Twitter's server. When you tweet, you're writing those to Twitter's server. The idea around data ownership in kind of Web3, people use the metaphor of a data backpack, where instead of traveling around from one website to the next with just a username and password and reading and writing to that server, you actually have your data with you. We could talk a little bit about where that data is stored, generally on the open web, but kind of the vision that is being built here is a world where when you show up to a new website, you can do an act of selective disclosure, essentially consent. And we all have a sense of what this looks like today. When you sign in with Google, you see that consent view that says, this application wants access to your contacts and calendar, and you click yes. And there's currently 3 parties involved in that. There's you, the individual, there's Google, who's holding the data, and then there's the application. We're talking about that being more of a one-to-one relationship between the individual and the application or their friends. And these data backpacks we're starting to see can contain things like your friends list, your interests, your addresses, and it's just a different kind of mental model for what the interaction can look like. There's a couple more to get into, as you can see here. But there's a big problem, and it was called out in the last talk, and it's a very, very valid one, that this stuff is hard to use. And the reason it's hard to use is down to this fundamental insight that digital signatures are the object that is used for identity in this new system. And as a result, what has happened is this whole system, you have to bring your own key. So you may be familiar with like Ledger hardware wallets or MetaMask. That is holding the key, your cryptographic key, the things that makes the digital signature possible, makes the authentication possible, like signing a transaction is a very common use case in crypto and Web3. Essentially, it's quite cumbersome, it's quite complex, it's really not ready for anybody except nerds. And so that's what we set out to solve. We've been working on this project for 2.5 years. The project is called Lit Protocol. It is a distributed key management network. The one really interesting thing at the heart of this is a cryptographic process called a distributed key generation. And the way that that works is a bunch of parties come together, which are the nodes on this network. They exchange a bunch of numbers, a bunch of polynomials with each other. And as a result of running that process across 30 nodes, for example, they have a key shared amongst them, where no one of the parties has the whole key, but each of the parties has something called a key share. You can think about that as a part of the key. And then a threshold is set. On our network, it's 2/3. So 20 out of 30 nodes have to authorize any individual transaction. And this moves the private key material away from the individual user and to a back-end service. And so this enables all kinds of really, really interesting things. And so I'll talk about that now. It has wide-ranging ramifications, as mentioned. One of the obvious primary ones is how to bring people into this ecosystem such that they can start using this distributed web technology. So for example, sign in with Google, sign in with passkeys, sign in with SMS, sign in with email. An individual user can just click a button. So for example, we have a partner that has built a Discord wallet bot where somebody can do a / command in Discord. The Discord credential, basically the sign in with Discord token, is passed to this distributed key management network that validates this and goes, yes, this is Alice. Let Alice sign transactions, call smart contract functions, whatever Alice wants to do. And Alice didn't have to save a seed phrase in this context. Alice just signed in with Discord. The key is held in this cloud wallet, but not like in the context of Coinbase or Binance, where there's a centralized custodian, but across this distributed fault-tolerant network where no person can use Alice's key except Alice. And that also means that if somebody goes out of business or one of these nodes is malicious or whatever it might be, Alice doesn't lose access to her money. And that's a really big deal. The other really interesting thing about this system is it also enables encryption. Doing something what is called identity-based encryption. You can think about that as like also conditional encryption. So if you've used Signal before, you obviously have a sense of what end-to-end encryption is. Basically, you're doing something called a handshake with the other party you're texting, where you are encrypting a message to their address, and then when they send a message back to you, they're encrypting a message to your address. That works great as long as the two parties know who one another are. But if you want to do something more sophisticated, like rules-based, for example, anybody who follows me on Twitter and owns this NFT can decrypt this data. That's a lot harder because that set is always changing. And to date, that kind of conditional or identity-based encryption was always handled with centralized key managers. These are publicly traded companies in the $10 billion range, like HashiCorp. Fortanix is another privately traded company that does this. With this kind of distributed key management system, somebody can store private data and create rules around who can decrypt it. And so this starts to get into that data backpack thing. When you say, oh, I've got my friends list, my home address, stored on the open web, but encrypted, and I have a set of rules around who can decrypt it. Any e-commerce website with a certain certification, for example, can send me offers. Starts to get really, really interesting. And then I will also talk about what's next for us. This is something that we're really excited about. We're just in the process of rolling this out. So as you can see in the last slide, these are some of the functions that developers use to do things like create wallets, encrypt data, sign transactions. But we are actually also releasing something in the very near future that we call domain wallets, and really excited to meet with some folks who want to explore this. And the problem isn't just key management, it's also the issue that the wallet address is this long string of letters and numbers that's very hard to use. And we really see the next step in terms of this lens around how can we make user interaction on Web3 something that is palatable to the masses. We need a human readable address. And so what we're releasing is this thing that we call a domain wallet. So if you have a website like toa.festival, we are creating a product where TOA can basically provision or sell or do whatever they want to do to give me david.toa, alice.toa.festival, so on and so forth. And that subdomain can be a profile on the TOA Festival website, but it's also a wallet. I can also use it to log into other dApps. I can send money to it. I can message from it, really as the sovereign kind of universal identifier. And essentially we see like identity unfolding in a world where Apple has an identity, Google has an identity. Those are the corporate identities. And one of our missions here is to make sure that people also have a fault-tolerant, internet-native, distributed identity that they can sovereignly own, but without making the UX sacrifices that are required to do that today. And with that, I will say thank you so much. It's a limited time. I would love to keep talking. Here's how to get in touch with me. This is my favorite topic in the world. We are literally bringing freedom to the web across this whole technological space. And we live in a digitally mediated society. So if we can bring freedom to the internet, I think that the long-term ramifications over the course of the next couple decades are just going to be so significant in terms of how people interact with applications and each other and think about themselves. Thanks again.